Look, you're sitting here right now. You exist. The chair beneath you exists. The air you're breathing, the light hitting your eyes, the planet spinning under your feet at 1,000 miles an hour. All of it, just there. And nobody asked it to be. Now here's the strange part. Physics, this magnificent enterprise that can tell you what happened a trillionth of a second after the Big Bang, that can predict the magnetic moment of an electron to 11 decimal places, that can describe the curvature of space around a black hole. Physics cannot tell you why any of this is here at all. Isn't that something? By the end of this talk, you'll understand exactly where science stops and mystery begins. And I don't mean mystery in a spooky way. I mean the kind of mystery that's so profound it makes your head spin. The kind that makes you realize we're all standing at the edge of a cliff looking into an abyss that swallows every flashlight we shine into it. Let's start with something simple. You wake up in the morning, there's coffee on the stove. You might ask, why is the coffee hot? Well, the flame is burning beneath it. The flame heats the metal heats the water. Fine. But why is there a flame? Because you struck a match. Why did the match ignite? Because friction caused the phosphorus to reach its ignition temperature. And on. Every why gets an answer, and every answer invites another why. Now here's what physics does beautifully. It traces these chains backward. It tells you the how. How does the match ignite? How does heat transfer? How do molecules vibrate? We can follow that chain all the way back to the Big Bang, that colossal eruption about 14 billion years ago when space itself began to stretch and cool. But then what? What lit that fuse? This is where something peculiar happens. When you push the question all the way back, you hit a wall. Not a wall of ignorance, though there's plenty of that. A wall of category. You're asking physics to do something it was never designed to do. You're asking the rules of the game to explain why there's a game at all. Let me give you an analogy. Suppose you're watching a chess match, a brilliant one. You study every move, every strategy. You learn the rules perfectly. You can predict what a grandmaster might do 3 moves ahead. Wonderful. Now someone asks you, why is there chess? Why do these 64 squares exist? Why are there rules at all? You see, all your knowledge of chess cannot answer that. The rules of chess presuppose the existence of chess. They don't create it. Physics is like that. The laws of physics, beautiful and precise as they are, presuppose the existence of something for them to describe. They tell you how matter behaves, how energy transforms, how space bends, but they don't tell you why there's matter, energy, or space in the first place. Here's another way to think about it. Imagine you're an ant living on a balloon, a very mathematically gifted ant. You discover that the surface you're walking on is curved. You work out the geometry. You even notice that the balloon is expanding every day. All the little dots painted on the balloon get farther apart. You're very clever, so you extrapolate backward and conclude that long ago all the dots were scrunched together at a single point. Marvelous physics. But can you, as an ant on the balloon, explain why there's a balloon? No. You can only describe its behavior from the inside. We're ants on a cosmic balloon. We can trace the expansion backward to what we call the singularity, a point of infinite density and temperature where our equations break down. But we can't peek behind the curtain. We can't ask, what was there before the balloon existed? In fact, as Hawking pointed out, the question might not even make sense. Asking what came before the Big Bang might be like asking what's south of the South Pole. You've run out of south. There's nowhere else to go. But wait. Slow down. Let me explain this to you as if you were a very bright 12-year-old, because that's when things become clear. Physics is the study of how stuff works. It's like being a detective who shows up after something has happened and figures out the sequence of events. But even the best detective can't explain why there was a crime scene in the first place. That's not their job. They need the crime scene to exist before they can start detecting. So physics gives us laws. Gravity, electromagnetism, the strong and weak nuclear forces. These laws tell us what happens when things interact. Drop a ball, it falls. But the laws don't explain themselves. Why is gravity an inverse square law? Why not inverse cube? We don't know. We really don't. We can show you that it works, that it matches observations to stunning precision, but why it has this particular form rather than some other, that's a different kind of question. Now, some very smart people have tried to sidestep this problem. You've probably heard claims that physics has explained how the universe came from nothing. There's been quite a lot of enthusiasm about this. The quantum vacuum, they say, is teeming with activity. Particles pop in and out of existence. Virtual pairs appear and annihilate in a frenzied dance. And maybe, just maybe, the whole universe popped into existence the same way. This is a tricky one. Let me be careful here. The quantum vacuum is not nothing. Let me say that again. The quantum vacuum is not nothing. It's something very specific. It's the lowest energy state of a quantum field. It has structure. It has properties. It obeys the laws of quantum mechanics. That's not nothing. That's something. Here's an analogy. Suppose I told you I made a fist appear from nothing. Amazing, right? But then you notice my hand was there all along. I just rearranged my fingers. The fist didn't come from nothing. It came from an existing hand in a different configuration. When physicists talk about particles emerging from the quantum vacuum, it's a bit like that. The vacuum is like the hand. Particles are like the fist. Something transforms into something else. But the underlying field, the stage on which this drama unfolds, that's already there. So when someone says the universe came from nothing, ask them what they mean by nothing. If they mean the quantum vacuum, they're not talking about nothing. They're talking about a quantum field governed by specific laws in a pre-existing mathematical structure. That's a whole lot of something. But here's what really gets me, and I want you to feel the strangeness of this. Even if you had a complete physical theory that explained how the universe emerged from some prior state, you'd still face the question, why does that prior state exist? Why are there quantum fields at all? Why is there something that can undergo fluctuations rather than absolute non-being? Leibniz put this beautifully about 300 years ago. Why is there something rather than nothing? He asked. He thought nothing would have been simpler, easier, no explanations required. But instead, here we are, swimming in existence. And no amount of physics will ever touch that question. It's like asking mathematics to prove that mathematics should exist. The tools can't operate on themselves in that way. Now let's talk about a common misconception. Some people think that if we just knew more physics, if we had a complete theory of everything, we'd be able to answer these deep questions. We'd explain why the universe exists. I don't think that's right, and let me tell you why. A theory of everything, if we ever get one, would still be a theory of everything. It would tell us how all the forces relate, how particles interact, maybe even how space and time emerge from some deeper structure. But it would still be a mathematical description. And here's the puzzle. Why does that particular mathematical structure describe reality? Why not some other structure? Or no structure at all? The physicist Eugene Wigner wrote a famous essay about this called The Unreasonable Effectiveness of Mathematics in the Natural Sciences. He was astonished that the abstract scribbles mathematicians make on blackboards turn out to describe the real world with uncanny precision. Mathematical concepts invented for pure curiosity with no application in mind later turn out to be exactly what physicists need. Complex numbers, group theory, Riemannian geometry, they were developed by mathematicians playing intellectual games. And then, boom, they're essential for describing quantum mechanics and general relativity. How did nature know to follow these abstract rules? Why does reality have a mathematical structure at all? Wigner called it a miracle. I think he was onto something. Let me give you a thought experiment. Imagine you had godlike powers and you wanted to create a universe. You sit down to design the laws of physics. What would you start with? Well, you'd need some entities to exist, right? Particles, fields, something. And you'd need rules for how they behave. Fine. But before any of that, you'd need existence itself. You can't have rules without things to follow them. You can't have things without the capacity for being, and that capacity, that raw existence, you can't derive it from anything. It has to be given. It's the starting point behind all starting points. This is what some philosophers call the problem of being. Not how does this thing work, but why is there a this at all? Physics takes being for granted. It says, given that stuff exists, here's how it behaves. But it never addresses the given. It can't. Now, some will say, well, maybe the universe is just a brute fact. It exists, and that's that. No explanation needed or possible. Bertrand Russell said as much in a famous debate back in 1948. The universe is just there, he said, and that's all. Fair enough. But notice what that does. It doesn't solve the mystery. It just declares the mystery unsolvable and walks away. It's like a detective saying, well, there's a dead body in the library, but I've decided not to investigate. I'm not saying Russell was wrong. Maybe the universe is a brute fact. Maybe asking why it exists is like asking why 2 + 2 = 4. It just does. But I confess that answer leaves me unsatisfied. My whole life I've been in the business of asking why, and when someone tells me to stop asking, I get a little suspicious. Here's another angle. Science works by finding regularities, patterns, laws. But a pattern presupposes something that exhibits the pattern. A law presupposes something the law governs. To even do science, you need a world. Where did the world come from? That's not a scientific question. It's a metaphysical one. And I don't say that to be dismissive. Metaphysics has gotten a bad name in some circles. But it just means thinking about the nature of reality itself, not specific things in reality. Let me try one more analogy. Have you ever played a video game? A sophisticated one, with beautiful graphics and complex physics engines. The characters in that game, if they were conscious, might study their world. They'd discover mathematical laws governing their motion, their collisions. They might even deduce that their universe runs on some deeper code. But could they ever figure out why their universe exists? Could they peer behind the screen and see the programmer? No. The code can't contain an explanation for the coder. We might be in a similar situation. Not that I'm saying the universe is a simulation. Don't misunderstand me. I'm saying our epistemic situation, our knowledge-getting situation, has limits. We can only study reality from the inside. We can describe patterns, test predictions, build technologies. But explaining why there's a reality to study in the first place, that may be forever beyond our instruments. Now, here's what I find beautiful about all this. It's not a failure of science. It's a recognition of what science is and isn't. Science is a method for understanding the workings of nature. It's spectacularly successful at that. But science isn't everything. There are questions about meaning, about existence itself, about why mathematics describes reality so well that fall outside its scope. And admitting that doesn't diminish science. It puts it in proper perspective. What then is the meaning of it all? I asked this question in a public lecture once, and my honest answer was, we don't know. After thousands of years of philosophy, after centuries of spectacular scientific progress, we still don't know why there's something rather than nothing. We may never know. And that's okay. It's okay to live with mystery. It's okay to stand at the edge of knowledge and peer into the darkness without filling it with premature answers. Some people find this disturbing. They want closure. They want to know everything is explained. But I find it liberating. It means we haven't exhausted reality. There's still wonder. There's still the thrill of the unknown. The universe keeps us humble. No matter how much we learn, there's always more, always deeper, always further. What does this mean for how we live? I don't think it changes much practically. You still get up in the morning. You still drink your coffee, do your work, love your family. But it might change your inner posture. You might walk through life with a little more awe, a little more gratitude that anything exists at all, including you. Because here's the thing, your existence is part of the mystery. You're not outside of it, looking in. You're made of the same stuff that has no ultimate explanation. You are the universe asking why it exists. The atoms in your body were forged in exploding stars. The carbon, the oxygen, the iron, all of it cooked up in stellar furnaces billions of years ago. But why were there stars? Why was there anything to explode? The question just pushes back and back and back until it dissolves into pure mystery. Physics has given us so much. It's revealed the age of the cosmos, the structure of atoms, the nature of light. It's shown us that space can curve and time can dilate and particles can be in two places at once. These are treasures, real intellectual treasures. But in all that dazzling success, physics has also shown us where the sidewalk ends. And beyond that edge, it gestures vaguely and says, I don't know. That might be where things just are. I started by telling you that physics cannot answer why anything exists, and that's true. But maybe the question isn't meant to be answered. Maybe it's meant to be lived, to be felt, to fill us with appropriate wonder. The greatest discovery, perhaps, is discovering how much there is still to discover, and how some of it may lie forever beyond our grasp. Thank you for listening. Now, here's my question for you. Does the fact that science can't explain why anything exists make you more curious, or does it frustrate you? Leave your answer in the comments below.